Bismillahirrahmanirrahim. Assalamu alaikum viewers and my dear students. How are you? Hope that you have been learning from Mathsnatic, uh, Cambridge IGCSE Mathematics from your teacher Tanveer Ahmed. Now let us proceed to next exercise. And before going to the next exercise, we should have to follow up uh, the laws. We have to we have to recap the laws for which the exercise is meant for. Now this exercise is meant for substitution. Will We have already learned about substitution in our previous lectures, but to recap what is substitution, we will do it for you uh, once again. Substitution means to substitute the numerical value in the variable to get some definite value is called substitution. Now, as you know that we supposed some number in our previous lecture, for example, the age of a woman, that was M, the height of the students, that was X. Now, these can be substituted by the numbers, by the numericals, by numerical numbers. For example, the age of the woman may be 15 years, 16 years, 20 years, 25 years, and the height of the students may well be 175 centimeter, 150 centimeter, and so on and so forth. And when we substitute the numerical numbers into the uh, variables, we will get the exact information for what the author was asking us about. Now, for example, we are given with a is equal to 2 and b is equal to 8. This is example which is written in your book. The a is 2 and b is equal to 8. If a is equal to 2 and b is equal to 8, then we have to evaluate AB. Then we have to evaluate AB. Now this is very simple. We'll substitute 2 instead of A. We'll substitute 8 instead of B and we'll get the exact answer. Now what will it be? 2 which has been substituted for A, and B 8. Now this has been substituted by B and we get the 16 answer over here. You notice that I have put a multiplication sign. Now here the multiplication sign was abolished, as you know. We abolished this multiplication sign from here. But when I return the numerical numbers, I put it again, because if I write it like this, it will be 28. It will be no more 2 multiplied by 8. It will be read as 28. Or even if I put a dot, which you must have studied in physics, dot product, even then it will be read as 2.8. So we have to put a multiplication sign back to its position. Similarly, there is another example for same, and that is 2a plus b. 2a plus b. Now we have to evaluate this as well. Now you have noticed that multiplication sign has been abolished from here. Multiplication sign has been abolished from here. So what we do, we put multiplication sign back to its position 2 multiplied by 2, 2, this one 2, and thus 2 for 2 is here, and again here you can still omit multiplication sign, because this bracket sign also stands for multiplication sign. Now a plus b, 2 plus 8. Now according to what my rule, you have to solve the bracket first. So 10, it will become 40. So here you see that how we substituted the values for a and b. Now my dear students, there are some more examples, and in this example a square, a rectangular and a triangle is given, and we have to find the perimeter of each. Uh, for, for each of the shapes in the diagram below, now suppose this is a diagram of square and this is the diagram of rectangle, as you know, and a triangle as well. Now I have drawn three diagrams: a square, a rectangle and a triangle. Now the side of the square is x. You know, when a square, one side of square is x, then that means that all sides of square are x, because every side is equal to the other. And if this is x, then this will have to be assigned to another uh, variable, maybe y. Now if this is x, the opposite side will also be x, and to this opposite side it is again y. Now for the triangle, there are some 6 triangles, uh, but I have drawn an equilateral triangle. So when you are coping up with the equilateral triangle, you have to now this is a triangle, a general triangle. I don't know if it is an equilateral triangle or an isosceles triangle or a scalene triangle or right angle triangle or obtuse or acute angle triangle. I don't know what is this. This is a general triangle. So the sides assigned to these are 2x. This is the example. I may tell you once again. Now the side assigned to this is x plus 3, and the measure assigned to this is x plus how much? 4. Now, we have got this three. We have got these three shapes, or you can say that these are the diagrams. Now we have to write an expression for perimeter of the each shape. Now what is the perimeter? First of all, we have to learn what is the perimeter. If you don't know the perimeter, you are unable to do what is author saying for you to do. The perimeter, suppose you are standing over here, and you keep on walking like this, and you go towards this direction, and you come back towards this direction, and again back to this direction. All the distance you have covered, is called the perimeter. Similarly, in this case, if you are standing here or you standing here, then you start from the journey through x, then y, then through x, and then y, and come back to your initial position. That means you have covered the perimeter. Similarly for this, you can, now the perimeter is the boundaries. The perimeter is the length of boundary. The perimeter is the length of the boundary. So write an expression for the perimeter for the each shape. Now you see that what I told you, if it is in centimeters, meters, millimeters, whatsoever it is. For for the square, for square, what we write here is we traveled from 0 point to this point, we traveled x, then we travel again x, and then we traveled again x, and finally again x. So we have traveled 4 x's, 1x, 2x, 3x, and 4x. When we sum up, we come up with 4x. You see that for each x, I told you in the laws that there is a 1 written when there is a variable written all alone, then it means that there is a 1 written at the left hand side of the variable, which is called coefficient. So 1, 2, 3, 4. So what we have traveled is 1x, 2x, 3x, and 4x. Now this is the perimeter of the sphere. This is the perimeter of the sphere. So in our second case, and which is the rectangular, we have traveled, if we travel, let us say from this point x, we first traveled x point, then we traveled y point, then again we traveled x point, and then back we traveled y point. So we have got with 2y's and 2x, so we write here 2x plus 2y. It is not finished as that. We'll uh, pick a common in between them, and that is 2. You see, the 2 is common in between them, so we'll write it like this. Now this is the length and this is the breadth. If it is given, but if I write it in another way, this is length and this is breadth. So this is the formula for perimeter. It will be written as 2l plus b. 2l plus b. This is the general formula for the perimeter of the rectangle. And similarly, if it is s means side, so it is 4s. It is the general formula for the perimeter of the square, perimeter of the rectangular, but we were given as x and y, so we solved it in x and y. Now, what about this triangle? Now, what about this triangle? We traveled p. These are p's. These are all p's. Now the p, 2x plus x plus 4 and plus x plus 3. You can even enclose all sides in brackets as well. Now we have to add up. You see that 2, 3 and 4, 4x plus 7. Now this is our perimeter for this very triangle. Now this is a very special triangle. I cannot assign to it the general rule for as I did it in square and rectangular. So this is 4x plus 7. Now in the second part, this was the first part of the example. Now dear students, the second part of the same example. The second part of the same example is that the perimeter was, what was the perimeter? You know, the perimeter was 4x. The perimeter was 4x, which I have rubbed it. because the first part was complete, so I rubbed it. Perimeter was 4x, or in general it was 4s. Now we have to uh, deal with this x only, because in your book the x is given. So perimeter was for the square was 4x. Now if the x is 4, now this is given, then what will happen, that p will be 4 multiplied by 4 is equal to 60 units. 4 multiplied by 4 is equal to 16 units. Now this unit may be centimeter, may be millimeter. If it not given, it is given. Yes, it is given that it is 4 centimeters. When it is given 4 centimeter, then you have to write it as centimeters. So this is 4 centimeters, 16 centimeter, and for this the rectangular. Now I have told you in the example the general rule of x and y. Now there is a little change in the dimensions of the rectangle. Now the breadth is equal to 3x and the length is x square plus 1. Let me find the new perimeter for this. For rectangular, p is equal to, now p is equal to 3x. Now there are two 3x. Now this is also 3x and this is also 3x. This is also 3x. So 3x plus 3x gives us twice the 3x. Twice the 3x, and similarly twice the x square plus 1. X square plus 1. Now we have to solve it first. Now this 2 will become as common. 2 is over here and 2 is over here, and all the matter which is enclosed in the brackets will be written like this. We'll write the second degree first, then the first degree, and then the one. So this is the whole equation. We have the whole expression we have obtained from this. If now x was given as 4, if x was given 4 centimeter, then we have to do it like this: 4 square multiplied by 3 into 4 plus 1. So what happens? You see that it will become 16, this will become 12, and 1 will remain as it is. So in final, what we get here is 28 plus 29, and it will become 58 centimeters. 58 centimeters. And now finally, for this, the perimeter for this was p, for rectangle triangle was 2x plus x plus 3 plus x plus 4. So there is 2x plus x, 3x, and 3x plus 1, 4x. 4x, 2, 3, 4, and plus 7. It will become, if it is 4, then it will become 4 multiplied by 4 plus 7. 16. 16 plus 7 is 23. So it is 23 centimeters. Now the perimeter is 23 centimeters. Last example of the today's section, and then we'll start exercise. Now the exercise is quite lengthy. We may have to split the exercise into two parts. So I am going to work the examples only. Now there is another example. Uh, example B in your book, and the page is 28. 3x plus x square plus 1. 3x x square plus 1 plus 3x plus x square plus 1 plus 3x plus x square plus 1. There is also plus over here. X square plus 1 and a plus over here. 2. Now dear students, this might be a rectangle as well. This might be a rectangle as well, because from the data given, it seems that this is 3x and this is x square plus 1, and similarly 3x and x square plus 1. So you see that all are added, 3x and 3x, x square plus 1 and x square plus 1. So what we have to do is we have to add the four lengths together and write it in its simpler form. Write it in the simpler form. So how we can do it like this? You see that this 3x can be added with this 3x. So we can write here 6x, and now this expression and this expression are the same. In fact, these are the lengths. So what we do here, we write 2x square plus 1. 3 plus 3, 6x plus. Now this is added with this. Now this carry 1 over here, this carry 1 over here. And if even you can multiply it with 2 as well to get the uh, addition of the 2. So in a simpler way, you can say that 1 is written over here and 1 is written over here. 1 plus 1 is 2, and the same expression is written over here. So this is complete. The first part is complete. We have written it in the simplest form. But he said that you have to write it, substitute 4 into the expression. 4 into the expression, instead of x we have to write 4. So now the x is equal to 4. I write it here somewhere. X is equal to, if x is equal to, if x is equal to 4, what will happen over here? That 6 into 4 plus 2 into 4 square plus 1. 4 square plus 1. Now what will happen over here? Now you see that this is a plus sign, this is a multiplication sign. We'll go for the multiplication sign, not for the plus sign first. So 24. Now this is being multiplied by this again. So what we do, we leave it here and we add the internal first. Now this is 17, and 17 multiplied by 2 is 34. This is 17. This whole is 17. 17 multiplied by 2 is 34, and the answer is 858. And if it is given in centimeters, it is 58 centimeters. It was quite an easy job. Now there is an example also. See example, x plus 3, x plus 4 and plus 2x. X plus 3 plus x plus 4 plus 2x. Now we have to do all the two operations for this as well. Now this is 1x, 2x and 2x. What will it become? 4x. 1x is over here, 1x is over here, and all the expression is carrying addition signs. So we can add them. 1x, 2x and 2 to 4x. And how many constants are there? 3 and 4, 7. 3 and 4, 7. 1, 2, 3, 4. 1, 2, 3, 4. X, and it will become, if it is again x is equal to 4 centimeter, then 4 multiplied by 4 is 4 multiplied 4 is 16 plus 7 is equal to 23 centimeter. 23 centimeter. The last example. Now in the last example there is a table given. Let me draw a table first. A and B. A, B. And how many values? 1, 2, 3, 4. 4. For this table, a formula is given also. And the formula is B is equal to 3A minus 3. And formula is B is equal to 3A minus 3. 3A minus 3. Now this formula is also given. This formula is given, this table is given, and some values are also given for the A. And the value for A are also given. And the values are 0, 2, 4, 6. 0, 2, 4 and 6. Now we have to manipulate each of the value and find its value and write it over here. So we start from 0. When 0 is substituted in this equation, what we get for B is 3 multiplied by 0 minus 3. Anything multiplied with 0 will become as 0. So it will remain as minus 3. So we will write here minus 3. This was quite an easy job. For 2, that is equal to 3 multiplied by 2 minus 3. It will become 6 minus 3. It will become 3. For 2 the value will be 3. For 2 the value will be 3. And for the 4, 3 multiplied by 4 minus 3, that is equal to 12 minus 3, and that is equal to 9. Similarly for 6, that is equal to 3 multiplied by 6 minus 3, that is equal to 18 minus 3, that is equal to 15. Now my dear students, this is an example which is given to you is for the linear graph. I'll tell you in my later stage what is the linear graph and what are its coordinates. Now these are the coordinates of this. I'll tell you what is a graph and what is a linear graph and what is a parabola and what is hyperbola and whatsoever it is. But this is a linear. Because you see, for each increase, for each increase, there is increase in the second variable. You see, here it is 2, it is 3, here it is 4, it is 9, here it is 6, it is 15. When one variable is increased, the second is also increasing. One variable is increasing, the second is increasing. Therefore, there is a linear relation between them. There is another example. I think it is in finished now. Yes, it is done. So, my dear students, we have done examples for substitution for today, and I hope the time is over and the period is over. So, stay tuned for our upcoming exercise, and don't forget to subscribe me and push the bell button. Keep on subscribing me, and keep on sharing with your colleagues and students. For next upcoming exercise, I say you Allah Hafiz.